Hey guys, and welcome to Petrol Ped. Now then, I've done many modifications over the last few years to Ruby Roadster to make her go really fast. I thought it's about time I made her stop as well. Sure is a beautiful morning this morning. I actually left home at Sparrows before the sun rose. It was pitch black, but it's now absolutely stunning. So, regular viewers to the channel may well remember, about this time last year, I did the Goodwood Marshalls track day. And at the end of that, my good friend Joe Achilles had his first drive of Ruby Roadster. But by the end of the day, my brakes were feeling a little bit sorry for themselves. They weren't really doing the job that they're meant to do. They're actually fine for road use, and to be quite honest, this car doesn't get many miles. I've done like 1,500 miles in the last year because I get so many press cars and I've got my Hendy car and so on. But I really wanted to up the braking performance of the car. I've spent lots of time modifying how fast it can go and how well it can go around corners, but I haven't done any work on how it stops when it gets to a corner. So I wanted to get a big brake kit. Now there's lots and lots of different options if you want to improve the braking performance of your car. So I thought, well, who makes the brakes for the Mini Challenge series? Because they're going to be perfect for my car, and that is Alcon. So I am on my way at the moment up to Tamworth in Staffordshire to visit Alcon because I want to have a look at how they make their brakes and all the other components. They make some of the best motorsport components and braking technology there is. Some of the most famous high performance motorsport vehicles out there have Alcon braking systems. So I want to see how they're made, the process they make, and what makes the Mini Challenge brake kit so good. And then at the end of the day, hopefully with a bit of luck, I'll be picking up a big brake kit for Ruby Roadster, which I'll then get fitted in a couple of weeks' time, because about a week after that is the next Goodwood Marshalls track day, and I want it all done by then so that I can take Ruby out on track and really feel what decent brakes are like for a change. So I finally arrived at Alcon, and I want to introduce you to the two guys that are going to do our tour and show me around today. Stood to my right. Emmeline, you're going to go first.
Yes.
Were you a group marketing manager, was that?
I am indeed.
So Emmeline's done all the logistics to get me here. And then, John, now you and I go way back.
We do.
If you've been following the channel a long time, 3 years ago, or was it 4? Please don't say it's 4 years ago.
3 and a bit.
Yeah, we did the Paris-Roubaix Sportif. And this man, he's what I call my Roubaix brother, but we met on the Paris-Roubaix Sportif. But you've been working for Alcon a long time.
I've been here for, blimey, 23 years, which is a long time. But I have to say, I still ache after Roubaix.
Yeah, I know, it's 3.5 years ago.
Certain parts more so than others.
So the format, we're going to have a tour around the facility, because not only do Alcon make the brakes that are going on my Mini, but you make brakes on some fairly special cars, from kind of Mini all the way up to the Aston Martin Valkyrie.
We do indeed, so we're going to show you some of those and how they're made and how they're tested.
Yes.
Yeah, Formula 1, GT, WRC, Mini, everything.
Yeah, so we're going to have a good look around the facilities. We might even get a peek in R&D. And then I'm going to meet with the guy who knows everything there is to know about my brakes that are going to go on the Roadster, but that is to come. Shall we go and have a bit of a tour? Okay, the very first machine we've come across is this CNC machine here that's taking a solid piece of aluminium billet like that and doing a pre-op. So it's basically removing the first amount of material. It makes an awful lot of swarf, but what comes out the other end is an Aston Martin Valkyrie caliper. Now, the machining time on something like that, on a 5-axis CNC machine, is about 10 hours of machining per caliper. Now, how cool is that? So here I am picking up brakes for my Mini from the same factory that's making the brakes for the Aston Martin Valkyrie. I think that's pretty cool. So the Valkyrie caliper we've just seen being made is machined from a solid billet. Now they're only making 150 Valkyries, so that's what, 300 fronts and 300 rear calipers. if you're going to be making 300 to 500 cars or more, then you're likely to move to this. So this is a cast one-piece caliper, and it's just about volumes of scale. But the other thing about the Valkyrie caliper is it's so complex a design, you'd probably struggle to cast it. So you take, this is how it would come out of the casting. I'm not sure how much of this is going to come across on camera, but then once it's been through the machining process, you can see now that I've got some machine faces on this, and the really interesting one is the holes inside here where my finger are, the boring that takes place. The actual machine, you haven't got room for the borer has to kind of go around a 90-degree bend. So it's just the intricacies of the machining process, and that's why I love coming around seeing how things are made. Okay, so we've done some calipers. Behind me are some discs. Now, all of the discs that are made here in the UK by Alcon are cast iron, actually. So this is an iron casting. It's an incredibly heavy component, and it goes through a number of processes here. First thing, it's got to goes through what's called a pre-op, which basically takes a lot of the main surface and just finishes things off a little bit. It then goes over there for a heat treatment phase, and then finally onto the machines over that way, where they'll get the surfaces cut onto the disc itself, the little fillets, designs, all the other bits machined out. And most of the discs, I think Alcon makes something in the region of 30,000 cast iron discs. They do work with partners on carbon ceramic discs, like for the Valkyrie, for example. But you've got these three different types of braking performance. You've got iron disc, which is what's going to go on the Mini, which actually is very high friction, so they work very, very well. The penalty you pay if I tried to pick up one of those discs is they're very heavy. So for things like unsprung mass, for some applications, they might not be the best way to go. Carbon ceramic discs are much lighter, but they get their braking performance. The carbon ceramic disc basically picks up brake material and carries the brake material, and the friction comes from the brake pad rubbing against the brake material on the carbon ceramic disc. So might see that in a short while. They actually have to pre-treat or bed in the disc so that it's got braking material on it. And then you go all the way over to something like a Formula 1 car with a carbon fibre disc and a carbon fibre pad. Now, interestingly, that has the lowest amount of braking friction, but they are the lightest component. And talking to John, it's quite interesting. You know, a Formula 1 car, yes, they stop incredibly quickly, but they have a huge amount of drag as soon as you lift your foot off the gas, and they're not very heavy. But for them, the most important thing is lightness. So for a lot of the motorsport applications that Alcon make their brakes for, yes, it's important that things are light, but the braking performance itself, and if you've got a really well-designed and well-made iron disc and a really good caliper, that's where you're going to get your braking performance from. But absolutely stunning to see all of these things being made. Now then, behind me are some very interesting brake discs. They're actually discs for the McLaren 720S, GT3 and GT3X, the new unlimited, no holes barred car that actually won the hill climb at Goodwood this year. Let me take you in for a closer look. So firstly, these discs are massive. I don't know how much of this detail you're going to be able to spot. I don't know if you can spot this little fillet here. So this has been machined out to balance the disc. So if you were balancing a wheel on a car, you'd add weight. When they're balancing these discs, they remove material to make them perfectly balanced. But the other thing is this paint. So this is actually a paint that reacts to heat, and the three different colours react to different temperatures. So when they hit the temperature that they're due to react to, the paint turns white. And it's a really simple ready reckoner for the engineers to look to see if the brakes are getting hot enough or not. So if you're not blowing this green one to white, basically the discs aren't getting hot enough, and you might adjust the cooling vents on the car to allow the disc to get hotter. If the orange one blows white, then that's your perfect operating window. And if you're going up to this one, then the disc's getting too hot, and again you might change the cooling ducts. You might also see the internal vents inside the disc. Now those are fascinating because you've got the amount of work, the kind of computational fluid dynamics that goes on to design those different vents. Firstly, the different designs can draw more air or affect the cooling of the disc, but at top level motorsport they can even affect the aerodynamic efficiency of the car. Mind totally blown. Now, I've now been allowed in quality control. Behind me is a CMM computer measuring machine doing the final inspection on a Valkyrie disc bell. We've got a bit of a Valkyrie theme running in this video, but hey, why not? The interesting thing is every single component that they make for Valkyrie is 100% inspected. So this machine behind me is basically checking all of the various measurements, making sure that they're within tolerance, and it's just a stunning thing. Now, I guess it's probably important to say they don't do 100% inspection on everything. It depends on the particular component. It might be 1 in 10, for example, but Valkyrie, every single component 100% inspected. Now then, anybody guess where I am? Well, I've come now to the R&D facility, and I'm actually in a dyno testing rig for the brakes. But this is a really special one. They've got a couple of different rigs here, and basically they can attach a disc and caliper system there, and then they can simulate the performance of a car. Now, it's not just about spinning the brake around at a certain speed, because if you think about it, you've got the weight of the car which is going to create inertia. So behind that wall, and on the other rig you can actually see them, they've got these massive flywheels that they can adjust based on which vehicle they're testing and how heavy it is and all those types of factors. And then they can spin the wheel round at up to maybe a couple of thousand RPM and start to simulate the different types of braking. And you've got the different hoses here you can see in the background. This is actually a Valkyrie caliper, so they've been doing some more Valkyrie testing in here. And they can simulate the correct airflow, and then they can put a whole bunch of different sensors on the caliper and make sure they're sort of testing temperatures and pressures in the oil and in the hydraulic fluid, those types of things. But the thing I've only really just found out about, this is an anechoic chamber. So one of the really big things that manufacturers of road cars have to deal with is something called NVH, noise, vibration and harshness. So when they make braking components, so let's just say discs and calipers, they have to comply to certain noise regulations so that the brakes don't squeal, for example. Now the problem with that is as soon as you start to do that, you actually compromise the effective braking capabilities of the braking system of the disc and the caliper. Well, in motorsport you don't have to deal with any of that, so all Alcon are interested in is ultimate braking performance. And if the brakes squeal, and we all make jokes about, oh, my brakes are squeaky, there must be motorsport brakes, that's why, because they don't care. And if you looked at a road car caliper, or on the back of the pads you'd have little shims, and they're there to reduce the noise and brake squeal. The other thing, this is a chamber where you can adjust the temperature and you can adjust the humidity, because again, temperature and humidity have a huge impact on brake squeal. So again, if you're an OEM and you're making a kind of road car brake system, then you need to comply to these regulations. And that's a big challenge, and some high-performance road car manufacturers are now saying, actually, for our high-end cars, Mr. Customer, if you want ultimate braking performance, you need to accept a little bit of brake squeal. Now then guys, next to me is Gary, who is Chief Engineer for Motorsport Engineering.
That's correct.
That is the coolest job title.
Thank you very much.
Ever. But I'm very excited because in front of us are my brakes. And they are immense. So we've got a gigantic set of discs and a very cool set of calipers. Oh, they're really heavy actually. So I thought it'd be really useful for the guys just to talk through exactly what we've got in front of us. Should we start with the calipers?
Yeah, absolutely.
So these are the calipers that run in the JCW series, the Challenge series.
Correct.
For Gen 2 cars. So just talk to me about the spec of these, because they just look absolutely sensational.
So yeah, so this is a two-piece forged aluminium post piston caliper. Has capable of taking a 330mm diameter disc up to a maximum thickness of 32. So plenty of thermal capacity available for discs underneath this caliper, and an uplift in size over what is fitted to the standard vehicle. One of the key things we like to do at first, just talking about the caliper, is to make sure that we design a caliper that has an inherent amount of stiffness. So we're just simply talking about how much the body deflects under its operational load. So the calipers have been designed, one, to be lightweight, so they're aluminium construction, but also with a design with stiffness in mind. So deflection of a caliper means long and inconsistent spongy pedal, which is not what you want, particularly when you are on the track. So yeah, so it's designed with stiffness in mind, and ultimately track brakes are about weight and performance, and that's what this delivers.
Because the interesting thing for me, I'd automatically assume that it was going to be able to push the pistons onto the disc with more pressure and therefore more stopping power, but I'd not really thought about the whole flexing thing. And I guess you do maybe with brake hoses, because I'm upgrading the hoses as well, because that's a rubber component and you can kind of get your head around that. So lack of flexibility, stiffness is super important.
It is, absolutely. So yeah, your hoses, for the same reason, any expansion within the hoses consumes brake fluid, and the brake fluid has to be delivered by the master cylinder, and that's pushed by the pedal, so that's the length of your pedal travel. So the calipers do the same thing, so you have to exert a clamp load on the pad to generate the brake torque to slow the vehicle down, and that clamp load will obviously need to be resisted by the stiffness of the caliper body. So if the caliper body opens, that's more fluid consumption, because the pistons come out of the piston bores. The fluid that's replaced in there behind the pistons has to be delivered again by the master cylinder, so that's all about pedal travel, pedal feel, which is the name of the game, really.
Wow. Now, I guess one thing to note, so these are full race brakes, right? So you can run these on a race car. The pad compound then has a determining factor on the drivability, because I'm going to be a combination of road and track driving. So I'll talk more about the pads when we fit them, but I'm not fitting the race compound pads.
Yeah, and that's important, because for road use you need the car and the brakes to work adequately when you go to the shops.
Yeah.
You know, when you're talking very low decelerations, very low amount of work for the brakes to do, and very low temperatures of the disc and the pad surface. So a full race brake is designed with its optimum window, if you like, to be higher up in the temperature range. Those race pads typically deliver either very poor friction at cold temperatures, or quite an abrasive friction at cold temperatures, which you could end up wearing out the discs very quickly just because they're operating too cold.
Okay, so for anybody thinking of like a brake upgrade, yes, you can kind of, there's a race caliper, but then the pad choice for your type of driving is really important.
It's critical. It is critical. So if it's combined driving, you kind of want a fast road pad, something that will work from cold and do so in a friendly way, but also something that's not going to start fading away when you give the brakes a bit more grief when you're on the track.
Well, this is it, because at the moment, although I've got a rated pads, the last track day I did, it wasn't good. It kind of ran out of, they just started screaming after about 5 laps. Then there's this disc, which it's just a work of engineering art, basically. So tell me about the disc.
So again, with the discs, there are a few things that you need to cater for with the disc. One, it needs to have the right amount of thermal capacity, so that's how much iron we've got in the brake to accept the energy input from the vehicle. And track use is about high energy usage at regular intervals. It's not just, a road car brake will be designed to do the same thing, so it needs to be capable of letting the vehicle go from maximum speed down to a complete stop in a safe manner. With the race brake, yes, we have to do that, but it also needs to be capable of being used again in a higher operating range more regularly. So this is about having the right amount of thermal capacity, but also about the right amount of cooling capacity within the disc. So again, vane geometry, vane count.
Is this a one-piece disc?
So that's a two-piece. That's a two-piece disc. It's got an aluminium bell, which again, compared to a standard road car, which are typically one-piece discs, the bell section would be iron, the same material as the disc. With this, we have an aluminium bell, so that takes out some weight out of the non-functional area of the disc in terms of thermal storage capacity. Most of that work is done by the what we refer to as the cheeks of the disc. So that's the iron plates. I'm going to put it down because it's really heavy.
The outer piece is machined from one piece.
Correct. Yeah. So we have a range of disc castings. Wow. This is one of them, and there's it'll be a large donut-shaped casting. So there is no bell piece on the casting in this instance. So we machine that ring from the casting.
Mate, they're just stunning things, aren't they? So this is going to help my car stop.
Absolutely, yes.
The next upgrade might be the seat belts to stop me going through the windscreen. Well, thank you for your time. I know for me, the interesting thing is a lot of people go and modify their cars. They make them go faster. They make them go around corners better by putting coilovers and stuff. But the last bit they often think about is making them stop. And the limited amount of motorsport I've done, speed's all about the braking, which is a counterintuitive bit.
Yeah, absolutely. Brakes are about confidence, and confidence typically breeds lap time. So they are absolutely critical to getting the maximum.
I don't think we should give up on the boy bands, you know.
No, I don't think so. Mate, I have found that fascinating.
Really?
Yeah, there's so much to brakes that I didn't know, and these guys won't know, and I just found the whole process fascinating. And actually, we've got a range of things we're going to talk through, but can we start with this, because we saw this at the beginning of the whole video as a solid piece of aluminium.
Yep.
And that's been machined and tested and painted, and that is an Aston Martin Valkyrie brake caliper.
It's nuts, isn't it? I mean, I obviously spend a reasonable amount of time here, and every time I see that piece, it's just staggering, isn't it? It's so beautiful.
Oh, it is.
And you can see the detail and why it is the way it is. I can't say I understand all the intricate detail, but it is a work of art. I'm glad you enjoyed it. It's fascinating.
And I didn't realise the whole difference between iron, carbon ceramic, and carbon fibre brakes. I'm now that's mind blown.
Myths.
Yeah,
there are quite a few of them out there, aren't there? I mean, it's if you don't know, you don't know.
Been fascinating. But, so what else we got here? So that's a clutch, right?
That's a clutch.
So,
and the reason we have clutches in our range, clutch is friction, because obviously it's a friction pack, so it's not too dissimilar to a braking system. And that's an ultra lightweight 5.5 inch clutch for a GT3 race car.
Wow.
So it's a beautiful little piece.
I mean, that's just a stunning piece of engineering.
It's lovely.
You'd have that as a desk ornament. So
yeah,
clutches,
beautiful.
A lot of people probably won't realise that you make clutches.
Yes, we make clutches.
And then this pedal box is, if that's a beautiful piece of engineering, it's
stunning.
Something else.
It is, and it's interesting because we refer to it as a pedal box, and people say, well, what is a pedal box? A pedal box is a pedal system that bolts into a race car or a high performance car. So it's a pedal system. It's got the 2 master cylinders for the front and the rear braking system, so it's obviously fully adjustable in terms of brake bias, hydraulic clutch, and that's a 3-pedal system, so it comes with the throttle position sensor as well. And this is a sliding unit. So in GT racing now the seat has to be fixed for safety reasons, and obviously 2 driver events, you could have a tall driver like you and a not so tall driver like me. We're not talking really short. But,
No.
And so the pedal system, the pedal box slides, and we have a lever by the driver's seat, and you hop in, pull the lever, set it against the stop there, and you've got your correct positioning. So yeah, that's a really interesting piece. We've been doing them for a few years now, and interestingly, whilst that's the GT race pedal box, we do the pedal box for the Valkyrie as well, and some other chassis components. But again, that is so beautiful. It's worth building a race car
just to put a
pedal box in. I might be biased.
And then the 2 out here, so this is aftermarket stuff that you do?
Yeah, it's an aftermarket caliper, so it's a 6-piston 2-piece forged caliper. It's right.
You don't have to go to the gym once you work here.
That's true. Lovely looking thing. So that'll be what you'd fit to your E90 M3, that kind of thing, if you wanted a full Alcon brake system. So it's a nice piece, like I say, 6-piston, 2-piece bolted caliper, but it's forged. You can have them in red, black, yellow, any colour you like. Nice large pad area, lots of clamping force, stiff caliper, and pretty lightweight really, given its size.
Looks ace.
It is.
Do you want to pass me that one?
No. In a word, no. This is an absolute beast. So
this is like 20. Did you say 23 kilos or something?
Yeah, it's in excess of 20 kilos. So what we have here, Pete, is it's an 8-piston, 4-pad, cast iron, heavy duty caliper for military type applications.
Yeah.
So that would actually be fitted to things like an 8-wheel 30+ ton vehicle.
Yeah.
These kind of vehicles, multi-wheeled military vehicles, really are very large rally cars. Obviously they carry people and other bits and bobs inside, but a lot of the technology that we've developed in WRC, for example, we can take through to that. And where you've got, for instance, a Valkyrie where you need a lightweight housing, on a military vehicle you actually need the kind of opposite. You need something that will withstand gravel, rash, shrapnel, etc. So hence the cast iron housing.
Yeah.
But it's the same technology, slightly different because we need different characteristics, but it's the same thing.
Very cool.
Pick it up then.
No, that's fine. It's all right. I'll leave it on the table because I have actually already tried to pick it up and it's really
very heavy.
So what you're basically telling me then is on my Mini, I'm going to have Valkyrie brakes, really?
Almost.
Yeah.
Almost.
And that's what's in this box?
Yeah, we for your car, we've gone slightly smaller because obviously similar weight probably to a Valkyrie, I guess.
Yeah, maybe not quite the same horsepower.
A little bit less, just a smidge less horsepower and a smidge less VMAX. So we've gone for a 4-piston, 2-piece caliper.
Yeah.
Which will fit inside your 17 or 17-inch rims, and it'll be perfect. But I think what we should do is try that, and then maybe try and do a super duper spec for you for later next season. That's really what we should do. Maybe Valkyrie shrunk.
Valkyrie down on a Roadster. I like it.
And why not? So they're in there. Yeah. Take them away. Enjoy. Feedback. Maybe we'll come out and have some fun with you.
Yeah. And we need to get out on the bike some more.
No. I'm still hurting from the last time.
We're not going to do Roubaix ever again.
Yeah.
Mate, I've got to thank you so much for today. I want to thank Emmeline as well, who's just behind the camera actually. She's been very good at kind of hiding away. But yeah, thank you so much for inviting me up here today. I've literally, my mind has been blown. I've just found it so interesting. And hopefully the idea behind this video was just to try and educate people a little bit more about the vast subject that is brakes, and we've scratched the surface.
It's like, first of all, it's our pleasure and you're welcome anytime, but it's like anything in life, no matter what you touch or see, nowadays there is so much that goes into everything, and hey, presto, brakes are no different. But thanks for coming up, it's been really good.
It's been mega. So I'm getting these fitted next week. I've got a track day the week after. I shall report back.
Lap record.
Well, we don't know about that.
Cheers.
John, thank you.
Thanks, Pete.
Guys, I hope you've enjoyed that. And as I said, massive thanks to all the team here at Alcon. But if you have enjoyed it, then give me a thumbs up. Comments below are always welcome. And if you haven't done so already, please subscribe to Petrol Ped for plenty more content to come. I'll put all of Alcon's details in the description below. And I'll see you on the next video with a very fast and very good at stopping Mini Roadster. See you on that one, guys. You take care. Drive safe.